Hello everyone, welcome to our TD course. In this course, I will help you hand in hand from the beginning of TD to the skilled operation of TD, and then to complete interactive or visual projects by yourself. Just make sure you have hands. Okay, so we're going to take you through a little bit of TD software in this lesson, and complete such a simple mouse-following drawing interactive project. The first is the download of Touchdesigner software. We can search for a software name like Touchdesigner in any search engine. On the official website of Touchdesigner, we can click it to jump to its official website. We can click here at Get It Now to get a link to download it. We will download the latest version of it here. I won't download it here now. What we use here is the non-commercial version, which does not need to spend money. Then you can also enjoy most of the functions of Touchdesigner. But it may have some limitations, such as the maximum number of pixels that can be exported from the video being 1280. And then there will be some higher level operator are not available. Moreover, you can't encrypt your project. But it is enough for us to study. Okay, let's open our Touchdesigner. When we open Touchdesigner, we may need to enter a password to download it for the first time. We need to register a TD account on the official website of TD. Then you can enter it here. When we enter the TD software, what we can see is that it first provides us with such a connection interface. In this part, we can delete it directly when we come in because we don't need them for the most of time. In fact, it simply shows us the simplest operation in this TD. Now let me introduce an interface layout of the whole TD. We have such a grid space in the largest area in the middle. When we click with the left mouse button and press it, we can drag left and right to change our perspective and position. When we have a big project, we may need to drag it frequently. To find the position of one of the operator, we need to adjust. On the far right of entire interface. This is a parameter of the operator we selected. Different operators have different parameters. When we select different operators, can be displayed parameters that can be adjusted by its corresponding operator. When we click on the operator with the left mouse button, it will be highlighted in green. That means we selected the operator. When we hold the right button of the mouse and drag it, we can make a multi-selection, and we can select all of them like this. In this way, we can select multiple operator to change positions, which is convenient for us to organize our connections and organize our network. On the far left of the entire interface, these are some of the official plugins that we don't need for the time being. In order to have a larger operating area, we can turn it off. Okay, on the right then is the parameter panel. We can press the P shortcut key on the keyboard to close or open it. Like this, we can press the P on the keyboard to turn it off. It allows us to have a larger visual range. You see, we often come out like just now. What is the reason? This is like our folder. For example, I just click on one, and when we come in, we see such a path. Who is in whom? Then it is also such a logic in TD. We see that we are now in a big container like Project 1. When we use the mouse wheel to drag back. When we keep shrinking, we can roll out of the Project 1 container. When we double-click on it, we can come back to this. For example, let's create another base now. Similarly, we can also double-click and click into the base just now. We'll click back. Except scroll back up, we can also click Project 1 to back up. At the same time, we can also use the shortcut keys on our keyboard. When we press I, we can go into the container we selected. When we press U, we can exit from container. When we press the keyboard shortcut H. For example, when we go somewhere else, we press H to help us get back to the center of our network. Okay. I just introduced a layout of the whole interface. This is the most important aspect of the interface layout that we need to know during the creative process. And then how we create operators. When we double-click the screen, we can create such operators. I will describe all the operators types in detail later. Another way is that we can right-click the opening on the right side of an operator that has been created before. In this way, it can directly connect the wire at the opening of the operator for you. Another way is to press the shortcut key. Instead of double-clicking, we press the Tab key on our keyboard. The Tab can also create an operator. Press Delete to delete the operator. When this operator has been connected to a wire, we can also create a new one. The difference is that if we right-click to create it, it will be created in the middle of this line. But when we click the middle mouse button to create, it will open a separate line to create it. Okay. Let's delete them. Okay. Let's delete all of this now. Then I will explain what kind of operators we have. The first is our top operator. The purple top lets open one of these operator at random. For example, we open a noise. We can see that it is an image form. So our top corresponds to the processing of all two-dimensional pixel images. It's all in purple top. Let's create a circle here. When we click to open our operator library, we can search in the input box above. For example, I want to create a circle. We can input C here. It can help us filter out all the operator with C. Okay, we found the circle. And we created a circle. Then let's talk about the green chop operator. The chop operator is also used in many places. The chop operator refers to all operators related to channels. We can create an operator like LFO. We can see that it is such a number that keeps changing from -1 to 1. There are more ways to play with it. For example, if I add a trigger at the end, you can see that it is a 0 and there is no number. But when I connected it to it, they will carry out certain data processing in the middle, and carry out data processing according to their different operator functions. I will explain them one by one later. The third is SOP. The operator is a blue operator, and this operator is more about the processing of some three-dimensional elements. For example, if we create a box, we can see that it is a three-dimensional thing with an XYZ axis. When we click the little plus sign Viewer Active in the lower right corner of the SOP operator, we can activate it by clicking it. When we move the mouse over it, we hold down the left button. We can turn its angle. By sliding the wheel, we can adjust one of its perspectives. Hold down the right button to make a pan. To see it. Of course, all the operations we do here are just a way of observation and a way of view. We turn off the viewer, the fourth MAT, the yellow operator library, which is less here because these are mainly our materials. We can see that these are two different materials. We will also give an explanation later. The fifth is the date operator. The date operator refers to, for example, we can find a text dat. The DAT operator is about text data. For example, text. For example, tables. A class of related such operators, including code, may also be applied directly through data. We don't need the last custom for the time being, so we won't explain it for now. The last one is our comp operator. The comp operators are some of these container operators, some of which are integrated and some of which can be used as folders. For example, the base we just used is an empty one, which is in the form of a folder that can be used for your entire project to sort it out. Or, for example, button, it is a button that has been integrated in a project. And we insert a null. Get around to see its data. For example, when we click it, it can provide us with a switch of 1 and 0. Alright, we've covered all the operator types. And the thing to notice here is, our operators can only be connected to operators of the same color. For example, I have a top here, and it is impossible to connect with SOP. And the tail of an operator cannot make a connection with the tail of another operator. When we click the right button, all the operator we can see here is highlighted. Operator that cannot be used will become gray. When we switch to another operator type, we can see, for example, chop. Only a few of these operators can be connected to top. For example, here we connect to an info. We can see that the connection here is not a solid line, but a dotted line. Here, chop displays a piece of information about top. For example, its pixel value is 256 times 256. Okay, let's delete info now. We use the circle and LFO we just created to teach you how to reference through chop. to control one of our visual effects. We can see here that this is a data that changes from -1 to 1. Here, we usually follow it with a null, which means blank. It doesn't really do anything. But this is a good habit, and we will often use it in later tutorials. What we want to do is to control the change in the size of the ball by changing the data from -1 to 1. Then we can find that in the circle. Radius represents one of its size. So we're here, let's say we change it to 0.1 and 0.1. And it becomes smaller. Okay, if we can reference the changing data to radius, we can successfully complete a real-time change in the size of the ball. So what we need to do here is to first click the small plus sign. Viewer active in the lower right corner of Chop, and when a green box disappears around it, we can put the mouse on it and turn it into a small arrow. At this time, we can drag this value into a right-pointing arrow. Drag to radius. We let go. We can see there are 3 selections to use. The first is Export Chop. We click on it. We can see that we have successfully realized the operation of zooming in and out of the ball with the change of data. But we can see that it may change too fast now, and we let it change a little slower. We can select LFO and reduce the frequency, for example, to 0.2. We can see that the change of the data has become slower, and the change rate of the data has become slower. At the same time, the data change here has become slower. Okay, let's click radius, and we can see that the specific radius corresponds to 1 and 2 and 3. These 3 values can be referenced of their changes. Here it is clearly written. Here we use a green one, which is the export chop just now. Here we exports a data like channel 1 of null 2. Okay, now we're going to change the other one, and we're going to do the same thing as before. When it turns into a little arrow, press and drag it to turn it into a chop preference, and click it to see it turn into a blue word. In fact, the effect is exactly the same. What is the difference here? The difference here is that when we use chop reference, it's presented here as a kind of Python code. When we used export chop, he simply moved one of its names. Relatively speaking, using the blue style of chop reference can have more possibilities of adjustment. For example, we can input a *0.1 at the back of the code. It is equivalent to that we make the number 10 times smaller on the original data. So we can see that it becomes an ellipse like this. Similarly, we divide by 10 here, which is the same effect. But if we had used the first export chop, it wouldn't have changed. There are 3 small squares in front of it. Select the first grid. Then it is an option for us to input data manually. When we choose the second blue one, we use the option of chop reference when we come over. We choose the third green one, which is our export chop option. Okay, the third one we moved over. Third, current chop value, we can know from the name. In fact, it simply obtains the instantaneous value of the data change. It's not very useful, and we may not have much chance to use it later. Okay, we just explained how to reference your own data through chop to change other data. Now let's learn how to make a copy and pass to reference another data to another new one. Here we go to build a new circle top. What we can see now is that radius here, circle 1 here. Radius here has been referenced by our data. We can right-click here to copy the parameter to it. We have a paste reference here. We can see that we just referenced the data of circle 1. Here we can see a dotted line. We copied the radius data of circle 1. Similarly, we can reference channel 1 of null 2 to it. Okay, when we right-click here and select Paste Expression, it is equivalent to just copying the expression of the channel 1 just now. A simple copy and paste. And there is the last one. In the center, we click on a copy parameter, and then to circle 1 here. It's also center. Let's click on Paste Bind. Look, it turns into a purple data. This data indicates that the two data will now be bound to either of them. To make one adjustment, can affect the other. Okay, we've learned a basic operation of the whole TD now, and the different types of each operation. We are now using what we have just learned to design and create a simple interactive small project. We just delete all of these. Let's create a circle first. Inside Common, we find Resolution. Here we can adjust the pixel of the whole circle, and now we can see that it is a square of 256 by 256. We want it to be the same as our screen ratio. We click on the small arrow on the far right of Resolution and click on a 1280 by 720, which is the largest size that the free version can display. We think the radius is too big now, and we can change it a little smaller, and change it to a ball like 0.05. Create a new chop. When we search for mouse in, we move one of our mouse data in, and we can see that it can get a coordinate value of our mouse. Okay. We click the right button to pick up a null after it. Click Viewer Active in the lower right corner of null. Click Circle 1. What we want to do is to make the ball follow the action of our mouse. We still have two values here. We first select the value of tx, and we drag it to radius. Let's drag it onto the coordinates of the first x in the center. Of center and click Chop Reference. You can see that it can now move around with our mouse. So in the same way, we reference the y-axis. Okay, we've now simply implemented an effect where a small ball follows the movement of our mouse. Okay, now I want to achieve a new effect is to allow me to click the left mouse button. It can achieve the effect of painting. When I release the left mouse button, the painting is stopped. We click on the mouse one, and we can give a name to the left button. We'll call it click. We have one more data like this. When I click the left mouse button, we can see that it changes from 0 to 1. We pick up a null behind the circle. Then follow the circle with a feedback. We often use the function of feedback, and I will explain it in detail later in the course. We add a level after feedback, which is also a very common option. If you use level, you can control a color value of our picture and its transparency. We click the middle mouse button behind null. Create a composite and connect the opening behind level 1 to the composite. Change composite operation to add. Add a null at the end. Okay, when we click on the little blue dot in the lower right corner of all the operators, we can see that it has a display. We can display it in our background, which is convenient for us to view a real-time effect. So what does feedback do? So we often use it to make a repetitive effect. Feedback can continually repeat the previous frame in this loop. For example, when I drag composite over feedback, feedback will be activated. You can see this feedback. It recorded the circle of all my previous frames. When we click the reset pulse key in feedback, it will refresh again. It will delete all the frames that were recorded before. I doesn't want my mouse to be displayed here as long as it's moving. Then we can use the click key just now. What I hope is that only when I press the left mouse, it will make a record. Okay, we can see that in our circle there is a fill alpha, which is the transparency of a fill color of our circle. Let's drag the click we just used here for a mapping. Chop reference. Now we can see that when I click the left mouse button, the ball will appear. Let's refresh it again. There is no ball now. When I click the left button, it appears. So what does the following level do? Level is for when I don't want me to draw here every time. NS all the painting would left. So I add a level in the back, and I can reduce the transparency of the last frame generated by feedback every time. For example, change it to 0.8. You see, they will slowly disappear according to the fade of time. We can see that I paused for a moment. In this case, this is a ball generated by the current frame. Its next frame is recorded by feedback. And the level is reduced. Decreasing the transparency by 0.8 is recorded here. And the next one is also recorded, and the transparency is reduced to 0.8 by analogy. All the balls are recorded here, creating a smearing effect. Now I want to make such an effect. Such a simple interactive effect that can be displayed in my screen. How do we do that? First, we're going to create a comp here called Window Comp. Click P. Drag the last top image we just generated into Windows operator. Okay, when we go to click on Open as Perform Window, it conducted a demonstration mode. Okay, I want it to be a full screen display, not a window mode like this. We go back by click ESC. We can make some settings here, such as border, which is the border of our windows. We don't want it. I also want it to be full screen, so opening size we change it to filling here. We fill it all with Perform. Okay, now we have a full screen effect. We ESC can back out. We can also do a Perform without clicking. We can click a small envelope in the upper left corner and we click it. But we will find that it is wrong. Why is that? Because we can see that in the path of the previous folder. There is also a Perform, which is another Windows. This is a window created by the system by default. Usually we can do this. We can do this by clicking the layout in the top corner here. We can divide the whole interface into two parts. Let's double-click and click into this folder. We select the Perform outside and we throw the last null 3. Put it into Windows as before. Throw it into Windows and we can see that its naming method is actually the same as our folder. Null 3 in Project 1. Okay, now we can see that it is also within the scope of our display. We click on the little envelope. Similarly, like the settings just now, we change opening size to fill and borders to close. We finally finished the effect. Okay, I hope this course can help you understand a simple operation of TD and help you get started. So in the next few courses, we will gradually go through some cases. After letting you complete some very interesting effects, let you learn how to use some of the most commonly used operators.